We have two things to do in this video. One is to describe what a couple is in relation to the turning effect of forces, and the second is to have some sort of equation to calculate the turning effect of a couple. Now, the turning effect of a couple is called a torque. Okay, so the two sentences at the top are what's really important. So a couple is a pair of parallel forces that are acting in the opposite direction. So if we look at the images, we have the plane, two parallel forces, one is going up, one is going down. We have the tap, two parallel forces, one is going kind of diagonally to the right, and one is going diagonally to the left. And the handlebars then, two parallel forces, one is going towards you, the other one is going away from you. So a couple is a pair of parallel forces acting in opposite directions. And what effect that will have is the couple will cause the rotation, but it won't cause a linear acceleration. So in the case of a plane, the plane will rotate anti-clockwise, where the axis of rotation is probably going right through the center of the plane. So the plane just rotates, but it won't accelerate up or down as a result of either of those forces, because the linear or translational effect of those equals zero. The same with the tap. So the couple causes the tap to rotate about the fulcrum, but it doesn't push the tap hinge or the top of the tap forward, back, left or right. And it's the same then with the handlebars. So it causes the handlebars to rotate about the fulcrum, but it doesn't push the bike forward or backwards. You'll notice then as well that I've got another image, which is a bottle cork or bottle top after being rotated off a bottle. So when you rotate the bottle cork off, you exert a couple on the bottle cork. So two parallel forces acting in the opposite direction allow you to rotate the cork off the bottle, but don't push the bottle forward or backwards. Okay. The formula for it is torque is equal to force by the force multiplied by the distance between the forces. Now for me, there are two moments in each case here. And what I would do is I would say get the moment caused by one of the forces and add the moment caused by the other force to it, because they're both making the objects rotate in the same direction. So I would be adding the two moments. That would be force multiplied by the perpendicular distance between the turning point and the line of action of the force, and then we'd have to add the same thing on again. So what essentially you have is F multiplied by D1 plus F multiplied by D2, where D1 is the distance between the first force and the axis of rotation, and D2 is the distance between the second force and its axis of rotation. And then because the forces are equal, if I take out a common factor for the force, I get the formula that's up above. So the torque of a couple is the sum of two moments, and when we take out force as a common factor, we get force by distance between the forces.